factor out the greatest common factor. We're still dealing with greatest common factor, okay? And this will expand even more. So to factor 12y squared plus 20y, we find the greatest common factor of, so this is 1, of 12y squared and 20y. We just did that a while ago when we find the greatest common factor of two terms. But now you are being given this polynomial here to find the greatest common factor when this is combined. So we will use the distributive property in reverse. Now the distributive property is will be as follows: a plus b, no, ab plus ac, that will give us a b plus c. So we will be going in the reverse process now. Okay, so let's start with it. So we have 12y squared plus 20y. Behind the scenes, this is what happens. We will get 20 and break 20 apart. Okay, so we will say now, 12, we're going to get 12 to be now what? So I'm going to work this piece here first and get that broken down there. So we have 12 to be 4 times 3, or 2 times, we can use this 2 times 3, which will give us 6 times 2, or 2 times 2 times 3, and that will give us 12. And then there's a y single, so we put a single y here if we want, or we put the y's here. So you will decide how you want to lay it this way, and then put times y plus 20 will be 2 times 2 times 5 times y times y. Those are the prime factors. Now I'm going to show you a shorter way also how to work it out, but it's the same concept. So now see what's common with them. Well, we have, if you notice, here it's, oh no, this is just a single y, so this should not have two y's. Sorry about that, just a single y. So notice here we have two y's, one y, so this is common, this is common. There's a 2 here, there's a 2 here, and there's a 2 here, there's a 2 here. So now if we were to work with this piece here, we would say 2 times 2 gives us 4. All right, but there's no 3 here, so you put here, we can put 2 times 2 times y, so that's 4y times 3 times y, 3y. Notice how we got that 2 times 2 times y here, 3 times y there. Now 2 times 2 times y, that's 4, okay, y, and then that's times 5 because there's 5 by itself. Now what is common in both this first term and this next piece of the expression? Well, they both have 4y, so therefore we can put now that 4y open bracket 3y plus 5. So we have just factored it out. This process is called factoring out the greatest common factor. Okay, so our next way we can work this out, I'll show it on the side here, is just breaking this down to smaller numbers. The reason why is that sometimes you may not see these numbers here right away. That is okay. So if you notice now, if I was to say that 12 is actually 4 times 3, there's a 4 in 20 also, so I can put, oh, but this is y squared, so I could put 4y times 3y. That is also 12y squared. Then we put here plus, and 20 is 4y times 5. Notice this step just went to this, and then they both have 4y on both sides, so therefore we get 4y 3y plus 5, and that's the same solution. So this is, if you're very good in your timetable, you will notice that they both can be multiplied by 4, these two terms here. So if you can't recall until that good, go ahead and find the greatest common factor of 12 and 20, and you start to find the prime factorizations. Okay, and so you will then get the factors of 12, and then you get the factors of 20. Having done that, now you then look what do they all have in common, but you must multiply them so you get those common terms. All right, so that is for finding factor or the greatest common factor of a polynomial. Let's go with the next one. And these examples, you need to pay keen attention, because as we go along, we'll start combining much more complicated. Factor 25 minus 5m. Do we have a strategy? You should always have a strategy. We will prime factor each coefficient of each term. Prime factor, okay? And then we will write each term of the polynomial as a product, which we just did a while ago, of the greatest common factor and one other factor. Why? Because we can then use the distributive property to factor out the greatest common factor. So let's start. Let me put here 25 and 5m. 25 is actually 5 times 5. The dot represents times in this case, and the 5m is 5 times m. Therefore, the greatest common factor is 5, because both of them have 5 in common, they don't have m. So we can use the distributive property in reverse to factor out the greatest common factor. So we do this. 25 5m minus 5m equals, well, we put 5, I put here in blue, times 5 minus 5 times m. We use the distributive property in reverse to factor out the greatest common factor. Both of them have the 5, so therefore we put 5 outside and then forget about those two 5s there. So we have 5 minus m, so put now bracket 5 minus m, and then we can say that the greatest common factor is simply what? Factor out the number 5 there, and okay, this is a continuation of the greatest common factor. It is often useful to factor out a common factor having a negative coefficient. What does that mean? Well, factor out the negative 1 out of this term here. Okay, there is a negative, positive, and negative. So what you will do is that you will take out a negative value and negative 1. So when you take out a negative 1 here, this becomes negative 1 times a cube will give us a negative a cube. A negative 1 from the positive, well, we're going to say a negative times a negative will give me a positive a squared, and then negative 4 times negative 1 will give me back a negative 4. and so we do that. So this is what we did here. This is what it means. It is often useful to factor out a common factor having a negative coefficient. Now, be careful. This is where the challenge comes in. For example, factor out the opposite of the greatest common factor in negative 18 a squared b plus 6ab squared minus 12a squared b squared. Well, it's the same concept as what as you see here, the negative 1. You're factoring out the negative 1 from the first term. So let's look at this one here. What is here? Well, for right now, don't worry about them being negatives, all right? You can go and find the greatest common factor of 18, 6, and 12. The greatest common factor of 18, 6, and 12 is then 6, right? You're supposed to be able to do that now. Then we have, because the first term was negative, we'll make it a negative 6. And then we have a squared, a squared. So notice that the a's is common in all of them, a single a, and also a single b is also common in all of them. Then we put our bracket, as in this case here, we have this negative 6ab times 3a gives me negative 18a squared b. And then negative 6ab times b. Well, the negative and negative will give me back a positive, so that's okay. And negative 6ab times positive 2ab will give me negative 12a squared b squared, and so we get this term. How do we get the greatest common factor of 6? Well, we do it this way if you want, but remember at this time you should be able to do the greatest common factor much faster. Or you look at the numbers 18, 6, and 12. What number can go into all three numbers evenly? 6 will go into 12, 6 will go into 6, and 6 will go into 18. So that's the greatest common factor of 18, 6, and 12. And since it's negative, we make one of the negative and get the just make it them opposite. All right. So when the first coefficient, as in this case here, of a polynomial is negative, factor out the opposite of the greatest common factor, which we do here. So this is the opposite.